Chapter 5, Parabolas. In this section we're going to be learning how to graph quadratic equations from one particular form, and that's vertex form. One of the things you need to know about quadratic equations is, well, how to identify them from the picture, how to identify them from the formula. So I'm going to have you fill in the standard quadratic form and the vertex form. The standard quadratic form is more for a future chapter, probably even the next section, but you need to know it. So let's just see it here. Y equals ax squared plus bx plus c. And sometimes that might be equals 0, but that's more for when you're solving it, not when you're graphing it. Sometimes that's difficult to get used to. But here's the key component to how to identify it as quadratic. The power is 2, and you don't see any other powers that are larger than that 2. You have a power for this particular term is 1, and I know I just wrote in yellow, and that's probably really hard to see, but I wrote a 1 there. It's because you wouldn't see it, you wouldn't write it. Something to the first power is itself, so you wouldn't say x to the first, you would just see x. And here's another thing, that's x to the 0. And x to the 0, anything to the 0 power other than 0 is 1. So yeah, that's a weird rule, but this means c times 1. But the reason I have these all written here is you can tell it's descending order, that this is the second degree term, the first degree term, and the 0 degree term. Quadratics are second degree functions, so it has a second degree term and nothing higher. Vertex form we'll get to in another slide, so hang in there. The name of the function is right here. It's quadratic. And the shape of the function, well, we might call it this U-shape. All of these are parabolas. They're U-shaped graphs. Their name is a parabola. So the name of the function is quadratic, but the shape of that function is a parabola. Alright, so this can be somewhat complicated, but we have something that's very similar to it, and that's the absolute value graphs, and I just want to cover that real quick because it's going to help. We had y equals a times the absolute value of x minus h, and the absolute value plus k, and that h value was a left or right move. And remember that the left or right move had this opposite there, so that was a little strange that you saw, say, a -2, and that said go to the right. If you saw a +1, that said go to the left. Another thing is that the k value is not grouped in the absolute value with the x. It's the number that's on the outside being added or subtracted. It's the up or down move. Now that does not have an opposite to be aware of. If it says +3, you're going up 3. If it says -2, you're going down 2. Then the a value right here, now that's a little bit more complicated. It will not be the same for quadratics, not quite, but this part of it actually is the same. If it was positive, it's going to open up, or if it's negative, it's going to open down. And here's one difference, this number 2 thing about a, that's going to be different for the absolute values, and that's in this absolute value graph, the a acted like a slope, and it's sort of the same with quadratic, but a little bit more complex, and well, certainly not linear at any point, so so no, not exactly the same, but kind of like it. Alright, but the good news is that these two things are so very similar. Here's your formula you just had on that last page, something you saw in a previous chapter, the absolute value graphs, and here's the quadratic function in vertex form. So if you're staring at that and that blank for the vertex form, there it is right there. So look at the similarities here. Almost everything is the same. The defining characteristic of the absolute value is the well, the absolute value sign, begin and ends this group, and the underlying characteristic of the quadratic is, well, here's the grouping symbols, and here is the power. So those are really the only two differences you see from just looking at the function. You see the second degree. What you need to think of is, all right, that is a quadratic, and the shape is going to be a parabola, so it's going to be U-shaped, and this is absolute value, so it's going to be V-shaped. Now they could open down instead if that were a negative A. So here is a little tool to show you the graph changing as A or H or K changes. So here they're all set to 1, but I'm going to change these so that they're 0 and then talk about them. I'm going to keep A 1 for a while. The first thing I'm going to change is the K. So the K is your up or down move. It makes you it acts like you think it's going to act. If it says plus, it goes up, minus, it goes down. So as I slide this to the right, here's K is 1, and you can see it moved up 1, and I could go maybe a little bit more readable. K is 2, and it goes up 2. And then if I go negative, here is a negative 2, and the vertex, it's still a vertex, just like with the absolute value. It's the turning point, the highest point or the lowest point, depending on, you know, the A value, whether it opens up or down. So the next thing I want to show you is the H value. Now watch out, because you might look at this change and see that it's not behaving like you think. It might behave like you originally would have thought, but here this says minus. So as I increase H, look at it go to the right, and you might be thinking, wait a minute, I know that if this says minus 2, then it goes to the right. Well, the minus is right here, not right here. So if this says H is 2, this would have read y equals A times the quantity x minus 2. You see that minus is still there? It would still say minus 2. So this is a little bit of insight into the mystery why they behave differently. Well, they don't really. It's just that as H increases, it goes to the right, but there's a negative in that formula. You're going to see that negative. You're going to think negative 3, negative 2 in this case. So you're thinking you're going to see x minus 2 squared, and it's got to go to the right too. So just beware. Just because you saw this go to the right as I move the slider to the right, it's still the opposite of what you would think. Now the A value, I'll show you a little bit about. It's the most mysterious, but it's kind of like the A value for absolute value. As I increase A, look what happens. It gets closer to the y-axis. I call that steeper or perhaps thinner. You can, if thinner is a little bit relative because you might be zoomed in, but closer to the y-axis is certainly a good way to say it. Now, as A decreases, it's just going to flip. All the A that have negative values, they open down. And if they open down, that means that the vertex is the maximum point and not the minimum point. Now look at what happens with, let's start A is 1. And then what happens between 0 and 1 is it gets wider or perhaps fatter. And I could even get more accurate, like 0.001. Now look at that. It is practically hugging the x-axis, but it will take off eventually. But I can, make this 0.01 and see it starting to rise. And I can make it 0.02 and make it rise a little bit more, 0.03, etc. So you can see that as A gets closer to 0, then it just gets wider. And as A increases 1, 2, 3, 4, 5, whatever, it just gets narrower. So you're going to have to be able to learn how to deal with that A value on your own. Oh, by the way, take a look at that one. A is 0. It's not actually a quadratic. That's just a line. See that? I could do whatever I want with H, and that's not going to change. I could raise the line, lower it, because what's happening here is all this is canceled because A is 0. So it's just like y equals negative 1/2. So A does have to be non-zero for this to be quadratic. Alright, so here's our first example, and we're going to take a while on it and deal with it in a number of different ways. But the first idea, or the first thing we need to do, is go find that vertex. So I see a plus 3. Now it's plus. That means I'm going to the left. So I'm starting here. It says minus 4. So down 4. And right there. So that's the most important point, and we found it. So what I'm going to do is I'm going to take that point, which is negative 3, negative 4, and I'm going to put it right here in the middle. And then I'm going to pick another x point or an x value and plug that in. It's not going to be too hard. I often have students who will take this and they will manipulate it, they will solve it and say, how do I deal with this? Well, just deal with it the way it is. It's going to be easy. I want to pick the next x values above and below, or left and right, of the negative 3. So I'm going to plug in negative 2. Now add 3 to negative 2 and you get 1. Square the 1, it's 1. And then I have 1 minus 4. 1 minus 4 is negative 3. So negative 2, negative 3, that's right here. And now I'm going to pick another point here. Negative 1. 3 plus a negative 1 is 2. 2 squared is 4. 4 minus 4 is 0. So 1 to the left and 0 up. That's going to be right here. And then I'm going to do one more. So I plug in x is 0. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 5. So 0 and 5. Alright, so this was the vertex. And if you look at some pictures of absolute value graphs, the vertex, either the minimum point for this one or the maximum point for either of these two, it is on what's called the axis of symmetry. And you know what symmetry is. It means that the left side looks like the right, or the top looks like the bottom, or something can be flipped over onto itself. So if I know this point is the vertex, then all I have to do to once I have this point is just see how far it was away from the axis of symmetry. Now, it might not always be the y-axis, just as in this picture, and I go that distance again. So let's apply that. So we'll come over here, and my axis of symmetry is through here, and so I'm just going to reflect this point over. It's 1 away from the line. It's going to land right here. This one, it's 2 away from the line, the axis of symmetry, so I'm going to go 2 on this side, and it's here. And this one's 3 away from the line, and it goes here. So if I put these points in the table, that would be negative 4, negative 3. It would be negative 5, 0. And it would be negative 6, 5. Now take a look at the y values as you go an equal distance from the vertex. They're the same. This is what the table would look like for you to see symmetry. And on the graph, it's how far away it is from this vertical line. The vertical line is x equals negative 3, right there, x equals negative 3. And that's your axis of symmetry. Now we're going to try and draw this parabola, and may take a couple of attempts, but you want to make it, pretty curvy. Try and hit those points. Yeah, it's pretty bad. There we go, not too bad. And then you should put some arrows here because it's just going to keep getting steeper and steeper, and we got our U shape.